Yesterday we were adding binomials. Somebody tell me what a binomial is. Christy. Yeah. All you're doing, binomials means they're two terms, right? Okay, and those are what we call linear expressions. So this is subtracting, I'm going to put this in here, linear expression, and these are also known as binomials, okay? So yesterday, when we did that assignment, all right, well, let's talk about, first of all, what that looked like. If I had something like 3x to the fifth minus 4, and I was combining that or adding to that, let's say 8 plus 2x to the fifth. Okay. When I did this yesterday, the first thing I did was what? Separate the terms, right? Okay, because all I'm doing is really, this is just like combining like terms. I just have these in binomial format. So what was the most important thing that I did? When I separated these terms, I had to look for variables, and in addition to variables, what? Exponents. So I look for the highest exponent. And in this case, the highest exponent I see across both these binomials was what? X to the fifth, okay? So I take this 3x to the fifth. I can't combine it with this or this, but I can combine it with this, right? So 3x to the fifth combined with 2x to the fifth will give me what? So 5x to the fifth. Now I cross this out because I dealt with those. And then I combine a negative 4 and a negative 8. The reason I can combine these is because they don't have any variables attached to them, right? Does anybody remember what that's called? Constant. Good. So a negative 4 and a positive 8 would give me a what? Positive 4. And I put a box around this because that's in simplest form, right? Okay. Good, good, good. So you understand that. Now, what we're doing today is going to be subtracting. Now, how many of you remember when we did subtraction of integers, and if I had two numbers that were not normal that I was subtracting, what was my rule? Does anybody remember? What was my rule? Copy, add, opposite, okay? So, when you're subtracting binomials, okay, let's say I have something like this. Let's say 7a to the second minus 2a, and I'm subtracting from that, let's say negative 5a plus 5a to the second. Okay, what I'm going to do whenever I am subtracting binomials, it doesn't matter, listen carefully, whether it's normal or not. I'm going to do copy, add, opposite. In other words, I'm going to take the entire binomial in the first part and I'm going to copy it. So this first part, I'm just going to say the same exact thing. So what's that going to be? 7a to the second minus 2a. This subtraction becomes what? Addition. Okay, and this entire binomial, in other words, all of the terms that are inside of it are going to be opposite. So what's the opposite of negative 5a? I'm going to add 5a, or I can just say 5a. And then what's the opposite of positive 5a to the second? Minus 5a to the second. Now, what we've done is turn this subtraction of binomials into an addition of binomials, or a linear expression, which is easy. That's what we did yesterday, right? So what we're going to do, we're going to separate our terms like we always do. Then I look for the highest power. What's the highest power I see here? 7a to the second. Can I combine that with 5a? They have the same variable, but they don't have the same exponent, so they're not like terms. So 7a to the second, and I combine that with a negative 5a to the second, what does that give me? A 2a to the second, okay, because it's subtraction. So I dealt with this, and I dealt with this, right? I have a negative 2a and a positive 5a. What does that mean? Smooth? Well, I'm not subtracting because this is addition. I changed it to addition. But I'm combining them, right? So a negative 2 combined with a positive 5 is going to give me a what? What kind of 3? Positive 3. So plus 3a. And when I get to this point, I look and see, can I combine these? There's nothing else I can do. The other thing that I want you guys to make sure that you check, are these in descending order? This is a power of 2. I don't see an exponent, so what does that mean? It's exponent is 1. So are these in descending order? Descending, by descending I mean from greatest to smallest exponent. Yes. So I can go ahead and put my box around it, which indicates that I have simplified this, right? Does that make sense? Okay. Does everybody have that copy down? Okay, I'm gonna write another one, and I want you guys to see if we can get that. Sometimes, like yesterday, sometimes I had some terms that weren't able to be simplified, right? If, for example, I have something like this. Let's say I have negative 12x to the fourth minus x to the second minus 3x to the third plus 2x to the fourth. Okay. First thing I look at is this subtraction. What is my rule? Regardless of whether there's positive or negative, what is my rule if I'm subtracting binomials? Copy at opposite. So this first one, I copy, and it becomes the exact same thing, right? Now, can I do something to this x to the second and make it a little easier to use? What can I do it? What can I do? Put a 1 in front of it, right? Does that change the value? Nope. What does this subtraction become? Addition. And everything over here, guys, there's mistakes to be made here. What I saw a little bit of in my other class is they just copied this down again. Okay, you can't just change it to addition without flipping or changing that second binomial to the opposite. Does that make sense? So this 3x to the third, that's positive. What does that become? So this is minus 3x to the third, and this plus 2x to the fourth becomes what? Okay, before I continue, does everybody understand these two terms became opposites, right? Because it's copy, what? Add opposites. So now, my next step is to separate the terms. So I'm going to separate this, I'm going to separate this. Look across the board. Question. Exponent. Well, because we're not done yet. We're about to be done. Okay? So I look at this from left to right. What's the highest exponent I see? 4. So I'm going to combine this, because it's an exponent of 4 and a variable of x. And this is a variable of x and an exponent of 4. So I'm going to combine negative 12x and a negative 2x. What's that going to give me? A negative 14x to the fourth. Dealt with this, dealt with this. Now, these both have a variable of x, so I can combine them, right? No, one has an exponent of what? The other one has an exponent of, well, which one's going to go first? This one, right? Doesn't matter that it's negative. My exponent is what I'm looking at. So I'm going to just, I don't have anything to combine it with, so what do? Bring it down. So this is minus 3x to the third. I have nothing to combine this with, so what do? Bring it down. So minus x to the second. First thing I look at, can I simplify this anymore? No. Are these in descending order by exponent? 4, 3, 2. So what can I now do? Put a box over here. Whoa. Sorry. Okay. Do we understand how to do this? Okay. Do we have any questions so far? Question. Mm-hmm. Okay, because we're treating this like this entire thing from here to here is the first number. This entire binomial is the second number. Because those parentheses are encompassing that. Does that make sense? If it wasn't, if I didn't have parentheses there, then it would be different. Okay? All right. Are we good so far? So you guys, try this one. Let's see if we can get it right. Negative 15 m to the fourth minus 2m to the sixth minus negative 17m to the sixth plus 3m to the third. Okay. Let's see if you can simplify this linear expression, please. Bless you. Don't hold them in. You're going to blow your eardrums out of your brain. Okay. Yeah, I've seen kids blow their eardrums by holding them. Don't do it. If you kept your eyes open, your eyeballs would see that. Okay, so is this subtraction of binomials? So what is my rule? Copy. All right, so this stays exactly the same. Agreed? What does this become? Addition, and everything over here is opposite. What's the opposite of negative 17m to the 6th? 17m to the 6th. What's the opposite of plus 3m to the 3rd? All right. So I'm done, right? No, I still have to what? I still have to combine these, right? So I'm going to separate my terms. What's the highest variable I see here? So I have a negative 2m to the 6th, and I have a positive 17m to the 6th. What does that leave me with? 15m to the 6th. I dealt with this. I dealt with that. Okay? So negative 15m to the 4th and negative 3m to the 3rd. Which one should I do first? Can I combine that with anything? So what do? Bring it down. And then can I combine this with anything? So bring it down. Now I look at this. Can I combine any of these? Are they in descending order by exponent? So what can I do? Okay, good. How many of you got that correct? Does this make sense? Okay. All right. If you look at this, it looks very, very difficult, doesn't it? It looks complicated, but it's not that hard. All right. That's what a lot of people think I sound like. All right.